Newton's first law of motion is called inertia, which means an object at rest will stay at rest unless acted upon by an outside force. Also, an object in motion will stay in motion unless acted upon by an outside force. Newton's second law of motion is that force equals mass times acceleration. This means that acceleration is inversely proportional to the mass of an object. Newton's third law of motion is that for every action, there is an equal and opposite reaction.
A common misconception about the first law of motion is that an object in motion will eventually stop. But this is false because gravity and friction are acting on the object, even though we can't directly see it. A common misconception about the second law of motion is that the speed of the object affects the force. This is not true because that would mean force equals mass times velocity, but force actually equals mass times acceleration. A common misconception about the third law of motion is that the larger the object will have a greater force than the smaller object when the two collide. However, this is false because the larger object has a greater mass but a smaller acceleration. The smaller object has a smaller mass but a greater acceleration. This allows the forces to be equal. Another common misconception is that an object is hard to push because it is heavy. While heavy objects can be hard to push, it is not due to their weight. It is due to their mass or inertia. Inertia is the object's resistance to change in motion, not the motion itself. Another well-known misconception is that heavier objects fall faster than lighter ones. Objects move down with the same acceleration, which is gravity, so they fall at the same rate. Lastly, a misconception about the laws of motion is that when the gravitational force and normal force are the same and there is no acceleration, that the object is stationary. However, this is not true because an object can still be moving at a constant velocity with no acceleration.
Due to inertia, this ball will stay at rest unless acted upon by an outside force. Since this ball changes its state of motion, there must be a force acting upon it, which in this case is friction from the grass. Due to friction and gravity, this ball will eventually stop. The force in the bottle is 4.4 newtons, since the mass is 0.447 kilograms and the acceleration is 9.8.
Even though these objects have different masses and therefore different forces, the acceleration of each is still 9.8 meters per second squared.
When she is walking, her feet and the ground are applying the same amount of force on each other because she is not floating nor falling through the ground.
When she pushes on the wall is pushing back on her with the same force.
When each of them pull on the force scales that are attached to each other, the force of tension allows the scales to read equally.
Since Newton's first law of motion is the law of inertia, we know that there can't be any acceleration. So right off the bat, we can ignore B and C. Because it is on the ground, there can't be any upwards motion. So from there, we can see that it has to be D, left, and it's constant. Since Newton's first law is the law of inertia, we know that there can't be any acceleration. And because there's no acceleration, and all we're given is this, we can't find any velocity. Newton's second law of motion states that force is equal to mass times acceleration. In this problem, you're given the mass and the acceleration, so you plug them into the equation to solve for force. In this equation, when using force is equal to mass times acceleration, you're given the force and the acceleration. That means you have to solve for the mass. So do that by dividing the acceleration by both sides to get your mass alone. In this conceptual question, they're trying to throw you off by saying large and small. Ignore that completely because what you're really looking at is equal and opposite force. In this last conceptual, you're really looking at the equal and opposite force. If it doesn't say force and it says equal and opposite change in motion, then it can be different because the sizes of the roach compared to your body is completely different. So since it's force, it has to be equal and opposite. This is a conceptual question based on Newton's third law of motion. Because Newton's third law of motion states that every action has an opposite and equal reaction, looking at the equation or at the problem, we can see that if you're slowly drifting away from the station and then you throw a tool away from the station, you're going to go back towards the station because it's an equal and opposite reaction. This last equation has 3 parts. First, find your given values. Once you're there, look at what it's asking. Since you know that you have to find the acceleration produced, you set force is equal to mass times acceleration. You have the mass and you have the force, so solve for acceleration. You're going to need to remember that number because you're going to use it later. Then, the second part asks, how far does it travel? Use your 2D kinematics equation, and you already know that you're going from 0, so the x initial doesn't matter, and your velocity is 0. From there, you just plug in your acceleration that you just found, and then time. That's what you find for your distance. Then the last part of the equation asks, what is the speed? Use your other 2D kinematics equation, and since you already know that velocity initial has to be 0, you can just plug in your acceleration and your time and then solve again.